June 12, 3 months ago, it was a very special day for me. It was my birthday. We usually celebrated a small ceremony at home with the kids. I also got a nice present for my little daughter. But this one was a very special day for me because we finally started our second clinical trial with our artificial cornea. It took us over 18 months of hard work to get there. At noon, we operated on our first patient, a guy from Paris who hadn't seen from 2004. And by that evening, this guy was reading numbers from my co-founder's iPhone 15, the first iPhone he ever saw. This item was aired on France Channel 5 Health Magazine just last week, telling the story. The guy immediately picked up the phone and called his wife. We got our lives back. That was the exact words, but in French. And I think we also found a solution for dry eye while doing so. CorNeat Vision started as an artificial cornea company, basically aiming to enable corneally blind patients around the world to completely rehabilitate their vision without the need for donor tissue. In order to solve this problem, what we actually had to address is the challenge of how to connect a lens, a synthetic material, to living tissue for life. And we've done that. Corneal blindness hits or impacts 2 million cases around the world, and only 150,000 of them are treated with donor tissue. 20 to 30% are repeated grafts, and the visual performance is really, really poor. This is actually the eye of our patient in Paris, and you can immediately see why he regained his insights. And while we humans know how to make lens, the trick is not in the optics. The trick is how to make the conjunctiva adhere and integrate that skirt that surrounds the device. CorNeat Vision was established in 2015 as an artificial cornea company, but as the time evolved, we've realized that the core material technology we developed to do that integration has 1,000x more potential. Today, we have 3 products in ophthalmology. The first was FDA cleared just a few quarters ago, and a first project outside ophthalmology, which is funded by the US Navy, applying that same core material technology to maxillofacial reconstruction surgery. We're vertically integrated in ophthalmology from sales to manufacturing, and for other applications, we're happy to partner. So far, we raised $20 million, including plus $7.5 million of non-dilutive grants from the EIC, the US Army, and the US Navy, of which we have yet to collect about $4.5 million. And we have a bridge loan to supplement these grants that take us all the way to the end of next year. So if you're a small investor, we have this bridge loan open, targeting early stage private investors to extend our runway. But I'm also here seeking lead investors that will invest in our next round, which we plan to open early next year. The main challenge our core technology address is the foreign body response around implant and how to integrate synthetic materials with living tissue. Everything that is implanted in the human body triggers that foreign body response that either degrades, expels, or eventually encapsulate that material. Nothing really integrates. What we're able to achieve is a material that is non-degradable and tissue integrating. And while originally it was developed to biomechanically attach that lens to the ocular wall, this can be used to permanently reinforce soft tissue, conceal other irritating implants, and also we've proven that it can be used for guided bone and tissue regeneration. Every surgeon we meet, regardless whether it's a gynecologist, a cardiologist, plastic surgeon, maxillofacial reconstruction surgeon, sees our results and immediately comes up with a few applications for our core material technology, some disruptive. This is the smoking gun showing how the material practically integrates within the tissue. You can see it here in the middle, our material interlaid between the layers of the eye wall. A few weeks later, it's filled with fibroblasts, collagen. We even see capillaries coursing the way through the material, and there is no encapsulation around it. We also proven that it's osteoinductive, meaning that osteoblasts actually grow into it and embed itself. So it's a new type of biomaterial. It's actually fully synthetic, and it combines permanency and tissue integration capabilities. And at both times, there's just no other material that works like this. And as I mentioned, the applications are many. One good example for the use of this material is the EverPatch, which we just launched to the US market. we've provisioned the first 500 devices to 60 ophthalmic centers. What the EverPatch does is displace the use of donor tissue or processed tissue in ocular surface surgery, so for trauma, glaucoma tube shunts coverage, and other applications on the eye wall. This is a perfect solution. It's also thinner. And here on the left, you can see what happens around our device versus tissue. There is just no foreign body response around it, and the eye is very quiet. A second example is our own glaucoma tube shunt that leverages the same material to seamlessly integrate it under the conjunctiva, but also avoid the encapsulation around the outlet, addressing the main challenge with glaucoma shunts today, which is the fact that they clog at a rate of 20% a year. So this is the first device that practically extends minimally invasive surgery to severe and refractory glaucoma patients, a segment that hasn't seen innovation in years. The glaucoma market is very vibrant, but all the deals are for mild and moderate cases. No one really addressed the real glaucoma that is a devastating, blinding disease. The device has additional innovation in it beyond tissue integration. The pressure regulation mechanism is another thing. We're able to implant this device in under 20 minutes in our first compassionate cases. And you can see here an histology that shows how it integrates with the eye as it traverses the subconjunctival space. In terms of go-to-market, as I mentioned, we're vertically integrated for ophthalmology. We have 20 independent reps that are walking the ground and promoting our first product, which doesn't have a large market, but it paves the road for the artificial cornea and the glaucoma tube shunts that follows and will be approved within the next 2 years. Around the world, we have started to sign up distributors, and in countries that rely on FDA regulation, we are already selling. For all other applications, we are open to partner, license, instantiate joint ventures that take our material and exploit its potential in other fields. One example is the project we have that is funded by the US Navy that takes this material to maxillofacial reconstruction surgery, either as a membrane for guided bone regeneration, as you see here, but also to coat titanium implants, which always have that interface challenge between them and the bone or them and the surrounding tissue. And we've proven that we can be that missing bridge for these types of application. So the project itself actually funds several advancements to our core technology, like hyaluronic acid coating and antibacterial capabilities. But basically, the proof is here. Here you can see this membrane can be used for guided bone regeneration, and the bone actually regenerates. A defect in the bone regenerates under this membrane. And here on the bottom, you can see full integration with the bone tissue itself. So following 2-3 weeks of this material being adjacent to the bone, you cannot disconnect it. In the next 3 or 4 years, we'll be introducing the 4 products to market, the ophthalmic direct. With the dental, we have partners that will take it to market, growing revenues to significant numbers. And here you can see why we are starting to raise our next round, which is $20 million, that will help us bridge the gap to profitability. We have a very strong and multidisciplined team. Myself, I already have done an exit. I spun off a company from a high-tech company and sold it to a US corporation, growing a $100 million business. That company was eventually sold to Microsoft for $20 billion, so I have my little scratch in the Microsoft portfolio. My co-founder and friend, Dr. Gilad Litvin, is the inventor of our product. He's an ophthalmologist, and he's on staff with us. And we have Gil and Sapir that kind of help manage the operations and business development. We're also supported by the world's top physicians in ophthalmology and now also in periodontology that are working with us very closely and advise us in all sorts of things. We are on a way to hit several significant inflection milestones, introducing the devices over time. And what we are looking for are partners that can join our journey. This is a company that can continuously generate value to its investors, divest, go IPO, and produce more products over time. Thank you.